let's get started and now create a block using Go. Imagine we have a server up here and that we have these blocks down below all stored inside a server. Regarding the data that's stored in the blockchain, we have the following data: hash, timestamp, nonce, and transactions. This timestamp here is where we store our value for time. Then this prev hash stores hash information based on the hash from the previous block. Later on, we'll get more into this in detail. The same goes for nonce, but put in simple terms, think of nonce as the answer that's calculated based on a rule. Then we have transactions. For example, let's say we have person A and person B. Person A wants to send Bitcoins to person B. For this scenario, we have the recipient address and sender address. And then for our value 1.0, and let's say this is in Bitcoin. Then let's say person A sends more Bitcoin to person B. We would see another transaction in our pool, and in this case, it's this 2.0. To sum this up, first, transaction data is included in our pool, and then these transactions are processed and verified by mining, and then added to our block under transactions. Once we reach a certain amount of transactions, then a new block is created. These are the data that's stored in a block, and let's move on to our next slide. Here we have a third block, and when this is generated, we see 2 transactions are stored. When we generate this block, our pool here becomes empty. And next, let's say that person X sends Bitcoins to person Y. At that time, a new transaction is recorded in the pool. Once mining is completed, then this data is stored in the transactions, and that's how we create our block. If you get the general idea of how blocks are created and what's stored, then you're doing great. Let's deepen our understanding by actually writing the code. The first thing we want to do is to define our block. Let's create some space here, so we're going to bring what we've written down to the bottom. I want to say type block struct. First, I'm going to include nonce int, and then next we'll say previous hash, and this is going to be string. Then we're going to write timestamp, and for this we'll use int64. Next will be transactions, and for this we'll be using slice string. Now that we've completed this far, and what we did is we took these 4 pieces of data and stored them in here. When we're going to create a new block, we can do so by writing func new block. There are many ways of generating a block. For example, you could write new and store block. And we'll create a struct nil setting for this B. Next, we'll write timestamp and create it with time now, and also store Unix nano. And for now, we'll simply return B and generate the new block. This is just one way, and there are many other ways of doing this. For now, I'll comment out and write return ampersand block. We have block and then this ampersand, which is the crucial part here. We'll return this, and let's write timestamp, and in this field, write time now Unix nano. This is another way of writing it. You could define the function in these ways, and you may wonder which code is actually better. The answer to this question can be debatable. For example, for the bottom solution, if we remove this ampersand and simply return block, this is one possibility. And then up here, next to our func, we remove our asterisk. In the case where you can define your function as simply block, then returning just block is fine. For this though, we see that we're going to return a pointer. First, let me erase this line with return, and now let's focus on this line with new. At this time, we've stored this pointer with struct into B. This is pretty obvious just by looking at this code. And if we use this new here, we'll return a pointer from a function. Which kind of code you want to use depends on what you prefer. But at this time, let's use this. You could also use nonce or previous hash. There are other ways of writing it. Let me include nonce in our argument, and also pass in our previous hash. Regarding this transactions, I'll get into the details for this later on. For now, let's just pass in these 2 arguments. Then for our B, we'll store nonce in this nonce. Then the same goes for our previous hash. We'll store previous hash here. This is how we create our function for new block. Now on to our next step. Let's generate our new block. We'll delete the section down below, and for B, we'll write new block. For now, we'll set our nonce to 0 and write init hash for our previous hash value. We'll write fmt print ln b and print b as is. When we run our code with this, we see down below 0, then init hash, then our timestamp, then our empty slice operator. How the results are printed like this may not be that visually easy to follow, so let's define how we want our block function to be printed. We'll say funcb, then block. We could override string, but if we do this, when we call on this directly, we won't be able to print in Go's format, so that's why we'll write print and create a method. Inside this, we'll print f, then timestamp, then after this, we have %d, followed by creating a new line. Then we'll pass in our b timestamp. We'll just copy this line and paste since we want 4 of these. Here we'll change this to nonce and replace this with nonce too. For the one below, we'll rewrite to previous hash. Same here, and previous hash is a string, so we'll change this to s. And for the last line, we'll rewrite this to transactions. This is also a string, so we'll change this to s. This is a method that we created temporarily to make it easier to understand our results. And please keep in mind this isn't a required step for creating the function. Now we want to print this, so down below we'll write print and run our code. And when we do, we see down below timestamp, nonce, previous hash, and transactions. This, I think, is visually easy to follow, and I hope this helped with your understanding of this lecture. Now that we've gotten this far, our next step is to create the structure for our blockchain. So let's move on to our next lecture.